continue our polynomial function discussion. That's what Unit 6 is over, is polynomials. So we're going to continue talking about that today. We're going to start by looking at a polynomial in the calculator. So I asked you to graph this function in the standard viewing window. What is standard viewing window? Got a -10 to 10 both on the x and the y. And zoom 6 will take you there very quickly. So that should have been the picture you got. Is that a complete graph? No. No. So state a window that shows a complete graph. Well, if I look back at what it shows, where do I need to go to see the graph? And how do you know? Down. How do you know that? You can kind of see the turning happening, and you can see that you can't see it all. At most, this has 2 turns in it. We learned that yesterday, so we're kind of looking for if we can find 2 turns. So, what did we change our y min to be? -20. Was that enough? Yeah, now I see what I would call a complete graph. Now, of course, I don't see every point on the graph, but I see a good picture of what it's doing. So, I have -10 to 10, -20 to 10. Is this the only correct answer here? No, there are a lot of correct answers. In fact, you could argue my y max might be too big, or we don't care as long as we can see the whole picture. Yes. From the original went in the standard viewing window, was it? Now, one of the things people do sometimes is they go, well, if I can just make it as big as I want, I'll just do -100 to 100 and -100 to 100. Does that always give you a good picture? Can you get too big? Yes. You can get so big that you can't see it. Other than that, we've got a lot of room for error in here. We can do a lot of different things. How many real solutions? What is a solution? A root, an x-intercept, they're all the same thing. What is it? It touches the x-axis. Now, real solutions and imaginary solutions are different. This, if you count real and imaginary, it has 3. Because the degree is 3. So I know it has 3 real and imaginary. But in the real world, how many times does it cross the x-axis? 1. So x-intercepts, or real solutions, there is only 1. A cubic, which we talked about this quickly yesterday. Cubic could have at most 2 turning points. A quartic could have at most 3 turning points, and so forth. A complete graph will show all turning points. Now, I do want you to remember this is at most. You could have a cubic that looks like that, right? It doesn't ever actually turn, right? It just has that little dip in it. You could have a quartic that just looks like this. Or you could have a quartic that looks like this. Right? So this is at most, so don't spend forever looking if there's only 1 turning point. But a complete graph will show all turning points. And page 422, which I think I mentioned that yesterday, has a good little summary of cubic and quartic functions. Okay, we're going to answer a bunch of questions about this polynomial. Today is a lot of calculator work. The first thing I'm going to do is put that function in y equals. If you can't see it well, it says x to the 4th plus 3x cubed minus 19x squared minus 27x plus 90. Anyone need me to repeat any part of that? Before I actually look at the graph, the first bulleted question has nothing to do with what the graph looks like. It says, what is the maximum number of turns? Well, what is the maximum number of turns?
3.
3. How'd you get the 3? It's always 1 less than the degree. Then the degree is the highest power. So yes. Okay, if I look at the graph, is it complete? And I'm not even in a standard viewing window, right? If I were in a standard window, it would really not be complete. Everyone agree? I can't quite see it all. So in a standard viewing window, this is not a complete graph. So let's make it complete. What do you think I need to do to make it where I can see the whole thing? Okay, which piece do I need to change? The X or the Y-axis. So she's saying negative 120 to 120. Would you agree we definitely needed to be all the way up at that 120 up at the top? Or somewhere close? Up at the bottom was negative 120 bigger than we had to be. Is that okay? Yes, as long as your graph is showing completely, and again, negative 1,000 to 1,000 is not what I'm looking for because it'd be hard to see. If you zoomed out on the X, would it make it hard to see? Like if you did negative 120 to 120 on the X, it would make it look real squishy, right? It would be close together and hard to tell. So, Peyton, if you're unsuccessful, don't worry about it. That's okay. I'll just print a new one later. Or we could just use the blank one in the binder. Because I can always print a new one later. Thank you for looking. I would give up by now. If I hadn't found one yet. We'll give up. I'll make a key off of that one right there. How many real solutions are there? And what am I looking for? I'm looking for when it crosses the x-axis. It is a little bit hard to tell right here, not as much on this one. So if you do need to go zoom in, do it. Does everyone know what I mean by that? This one I think is pretty easy to tell, but if you can't tell if it dips below or if it just touches, go zoom in on it and see. This one clearly crosses 4 times. Do we agree? So, what are they? Well, now we need to find out how to find x-intercepts. What are some options for doing that? Set it equal to 0. Can I do that from the graphing screen? How? There are actually 2 ways. One that you probably have as a favorite that we use a lot. Put 0 in y2 and find the intersections. Will you be able to find intersections if you don't put 0 in y2? It'll just keep clicking and saying second curve question mark. You know what I'm talking about? So put 0 in y2. And I need to find all 4. So I'm going to go to second trace, number 5. get close to an intersection. I'm going to start with the very far right intersection. And I'm going to push enter 3 times. And I get 3. Just for fun, I'm going to show you the zeros button. To me, it's a little harder to use and people mess it up a little more. That's why I teach you intersection. But you don't have to have 0 and y2 to use the zeros button, so it's nice to know. Also, second trace number 2 is the zeros button. You go to an x-intercept, and then you go to the left of it. You see how it says left bound question mark? So you go to the left of the 0 and you push enter. And then you go to the right of the 0 and push enter. Don't go so far right that you go past the next one, because then you don't know which one it'll give you. Push enter again, and you get 2. So the options for finding x-intercepts in my calculator. Third option, and I've mentioned this and I've shown it to you before, but it's been a while. There is an app that you can get in your calculator called Poly, SMLT2. Oops. If you don't have it and want it, let me know. And there is a polynomial root finder. Isn't a root and an x-intercept the same thing? The only difference is this will also give you imaginary answers. If the answer has an I in it, the degree of the polynomial is 4. Order and degree are the same thing, so the order is 4. Everything else you can glance down at. Most of the 4th, x cubed, the constant. If any coefficients are skipped, you have to type a 0. For example, if there is no x squared, you have to type a 0 on that piece. -3, +3.